Hello, as we have said in our previous lesson, there are 4 standard congruence tests and proofs for congruent triangles. Today we will look at the first 2 proofs. We will look at side, side, side and side, angle, side. Okay, firstly we will look at the rule side, 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 which means 3 sides are all the same. So if we have 3 sides the same, then the 2 triangles must be congruent. Now, down in the bottom diagram here, we can see why just side, side is not a rule. We need that third side to be the same in order for it to be a rule. Because we can see here, in each of these diagrams, they all have a 5 centimeter side and a 12 centimeter side, but they are definitely not congruent triangles. So we need the third side to be the same so that they are congruent, otherwise they are not congruent. This diagram shows the same 2 sides, the 5 centimeter side and the 12 centimeter side, and then we have the third side as 10 centimeters. When all 3 sides of a triangle are given, there is no freedom of movement, and only one such triangle can be constructed, which means that they have to be congruent. All the sides are then the same, meaning that all the angles are also the same. So triangle ACB is the same as this triangle down the bottom here. We'll call that triangle ADB. So just saying that one more time, once we have an included side, it means that these other sides can no longer move or change length. So the 10 centimeter side means that the rule side, side, side is proof of congruent triangles. And here we have the SSS congruence test. The initials SSS mean side, side, side. So if we are given 3 sides of a triangle, the lengths of the 3 sides of a triangle, then only one such triangle can be constructed. So therefore, any triangle that is constructed with the same 3 sides has to be congruent to another triangle with sides of the same length. Okay, so let's now look at our next rule, which is side, angle, side. In the diagram here, we can see we are given 2 sides that are the same, the 6 centimeter side and the 4 centimeter side, and then an angle of 30 degrees in the middle of the 2 sides that is the same. From the diagram, we can quite clearly see that the remaining side, AC, has to be the same length in any triangle that has these measurements. Any triangle that has a line AB of 4 and a line BC of 6 centimeters with a 30-degree angle in the middle of the 2 sides, the only line that could possibly join here has to be the line AC. So when we have a look back at our side, angle, side congruence test, it states it's if 2 sides and an included angle of one triangle are respectively equal to 2 sides and the included angle of another triangle, then the 2 triangles are congruent, which we have shown in the previous slide. So if we are given 2 lengths and an included angle, the only one triangle can be constructed. Only one triangle of the same shape and the same size. So drawing an example down the bottom, say we have a 2 centimeter side and a 3 centimeter side with an angle in the middle. These have to be congruent triangles if we draw the same down the bottom here with the same angle and the same length here. The only line that can join up here has to be the same as this line over here. So that means the side, angle, side proof for congruence is true.